I'm Mallory and I'll be teaching limits to infinity. So when given a problem asking for the limit to infinity, it will be written as the limit as x approaches infinity of f of x, which will equal c, which is a constant. And when dealing with limits to infinity, it is important to remember that as the denominator gets larger, the answer will get closer to 0. So as this graph of the limit as x approaches infinity of 1 over x and the limit as x approaches negative infinity of 1 over x shows, as f of x gets smaller, x is approaching infinity and the limit is becoming 0. This example of the limit as x approaches infinity of 1 over x squared and the limit as x approaches negative infinity of 1 over x squared shows the higher the exponent in the denominator, the faster the function gets to 0. So there are three cases that you will encounter when dealing with the limits to infinity. The first one is when the degree of the numerator is greater than the degree of the denominator. In this case, the limit equals the degree of the numerator divided by the degree of the denominator. So in this example, you can see it says the limit as x approaches infinity of 2x squared plus 5x plus 5 divided by 3x squared minus 2. So you will do the degree of the numerator, which is 2, divided by the degree of the denominator, which is 3, and that's how you will find your answer. The second case is when the degree of the numerator is less than the degree of the denominator. When the degree of the numerator is lower than the degree of the denominator, the limit will be equal to 0. So in this example, you see that the degree of the numerator is 5 and the degree of the denominator is 7. So since 5 is greater than 7, or since 5 is less than 7, your answer will be 0 when finding the limit as x approaches infinity. The third case is when the degree of the numerator is greater than the degree of the denominator. When the degree of the numerator is higher than the degree of the denominator, the limit is equal to infinity. So you will see here that the degree of the numerator is greater, which is 3, than the degree of the denominator, which is 2, and so therefore it's infinity. So an example would be the limit as x approaches infinity of 2x squared plus 5x plus 5, all divided by 3x squared minus 2. So you will separate them by writing the limit as x approaches infinity of 2x squared plus 5x plus 5 divided by x squared divided by the limit as x approaches infinity of 3x squared minus 2 divided by x squared. And you'll be using x squared since that's the degree of both the numerator and denominator. And so you will set all of them over x squared. Each portion of the function will be placed over x squared in the numerator and also in the denominator. And you will cancel out the terms and you will end up with the limit as x approaches infinity of 2 plus 5 over x plus 5 over x squared, all divided by 3 minus 2 over x squared. And so you will go through the problem by writing the limit as x approaches infinity in front of each of the terms in both the numerator and the denominator. And when you solve the problem using the rules that were taught earlier, you will realize that the answer will become 2 plus 5 times 0 plus 5 times 0 in the numerator, which when you solve will give you 2, divided by 3 times 2 times 0 in the denominator, which will be 3. And so you will have 2 over 3 as your answer, which is what we learned would be the correct answer since the degree of the numerator is equal to the degree of the denominator.